Welcome to the DIY Honda Garage channel. The DTC P1109 refers to an issue identified within the Barometric Pressure (BARO) sensor circuit, indicating an out-of-range high reading. This trouble code primarily affects the engine control module (ECM) and power control module (PCM), key components responsible for managing engine operations and sensor data processing. The BARO sensor itself is usually located in the intake manifold or within the ECM/PCM housing, and it measures atmospheric pressure, which is crucial for optimal engine performance. A malfunction can lead to improper air-fuel mixture adjustments and may result in performance issues. When diagnosing this DTC, it is vital to collect freeze-frame data, which captures engine conditions at the time of the fault, along with onboard snapshots to systematically address the issue. The situation necessitates careful troubleshooting steps to ensure a thorough understanding before rectifying the error. The DTC P1109 indicates a problem in the barometric pressure BARO sensor circuit, specifically indicating a high value that is beyond the expected range. The BARO sensor plays a significant role by allowing the ECM/PCM to accurately gauge the atmospheric pressure, which is critical in determining the optimal air-fuel mixture for combustion. Misinterpretations of this data can result in erroneous adjustments to engine parameters, leading to suboptimal engine performance or potential failures. Typically, the BARO sensor is located within the intake manifold or the ECM/PCM assembly, making it relatively accessible for inspection and testing. A malfunctioning sensor could signify either a physical issue with the sensor or a problem within the circuit connecting it to the ECM/PCM. Accurate understanding of this fault is essential for effective troubleshooting. Several potential causes can lead to the triggering of DTC P1109. First, a faulty BARO sensor itself is a common culprit. If the sensor has degraded or failed, it may send inaccurate readings, leading to high circuit output. Another possibility is damaged wiring or poor connections within the circuit, which could either short out or corrupt the signal being transmitted from the sensor to the ECM/PCM. Additionally, an issue can arise from outdated ECM/PCM software. If the software does not support the correct functioning of the BARO sensor, it may misinterpret the readings. Finally, environmental factors, such as corrosion or moisture intrusion in electrical connectors, can also result in an erroneous high reading from the BARO sensor. Understanding these causes is critical to effectively diagnosing the trouble code and ensuring all components are functioning as intended. Drivers may notice several symptoms when DTC P1109 is present. One of the most common indications is a noticeable decline in engine performance. This could manifest as hesitation during acceleration or poor fuel economy, due to the erroneous air-fuel mixture being utilized. Additionally, the check engine light, CEL, will illuminate on the dashboard, alerting the driver to potential engine issues. Rough idling conditions may also be evident, as the engine struggles to maintain a steady operation due to incorrect atmospheric pressure readings. These symptoms can lead to further complications if left unresolved, emphasizing the need for a thorough diagnostic approach to address the underlying issues associated with DTC P1109. It's essential to diagnose and rectify this trouble code promptly to restore full vehicle functionality. The first troubleshooting step for addressing DTC P1109 involves resetting the engine control module, ECM, or the power control module, PCM, using the Honda Diagnostic System, HDS. This reset is aimed at clearing any stored fault codes, allowing for a fresh start in diagnostics. The HDS is a specialized tool designed for Honda vehicles, providing technicians with a user interface to perform resets and conduct in-depth diagnostics. After performing the reset, the technician should start the engine and observe its behavior. This initial step is critical for ensuring that any previous irrelevant codes do not interfere with current diagnostics, and it allows a chance to see if DTC P1109 reappears immediately after reset. Proper execution of this step sets a solid foundation for moving through the remaining diagnostic procedures. In this second troubleshooting step, the technician rechecks for any pending or confirmed DTCs using the HDS. This process involves utilizing the diagnostic tool to retrieve any fault codes that the engine may have generated following the reset. The focus here is to determine if DTC P1109 is still indicated. If DTC P1109 is present again, it suggests that there might be an ongoing issue that needs further investigation. If no DTCs are present, this implies that the previous fault could have been intermittent, indicating that the system may currently be functioning correctly without further troubleshooting required at this time. Other pending or confirmed DTCs that may appear need to be addressed, as they could indicate other issues requiring immediate attention as well. Understanding these readings is essential for an accurate diagnosis. The third troubleshooting step focuses on the need to update the ECM/PCM software if outdated. Manufacturers periodically release software updates that fix bugs or improve functionality for various components, including the BARO sensor. This step entails determining if your ECM/PCM is running the latest version of the software. If not, an update through the HDS should be performed. Alternatively, if issues persist even after the software has been updated, substituting with a known good ECM/PCM can confirm if the original module is faulty. It's crucial to ensure that any replacement or update adheres to specific programming requirements, as improper installation can lead to further issues down the line. This step addresses potential software conflicts and is critical for ensuring that the control modules function appropriately with the sensor circuit. In the fourth step of troubleshooting, the technician again checks for pending or confirmed DTCs using the HDS after the software update or ECM/PCM substitution. If DTC P1109 still appears, indicating that issues persist, the technician must take further action based on whether the ECM/PCM was updated or substituted. In cases of software update failure, replacing the ECM/PCM with a known good unit becomes a necessity, followed by another diagnostic review. If the original ECM/PCM was substituted, but the DTC still appears, it can confirm that the original unit was defective and should be replaced. Conversely, if the code does not reappear after these steps, the previous actions confirm the troubleshooting process as complete, indicating the system is now functioning correctly. Executive decisions here require technical knowledge to ensure that the steps taken are justifiable and measurable. For final repair verification concerning DTC P1109, it is essential to confirm the successful clearance of the trouble code from the system. This involves using the HDS again to check if the DTC has been cleared and remains absent after the previous repairs and replacements. Following this, a test drive should be conducted to ensure that the vehicle operates smoothly without any complications or symptoms previously associated with the trouble code. During the test drive, the technician should monitor the engine performance closely, paying special attention to how it responds under various driving conditions. This step is crucial as it confirms whether the issue has been fully resolved and reliable performance has been reinstated. Final verification helps ensure that the repair work conducted has adhered to diagnostic standards and promotes lasting vehicle reliability. Preventive maintenance is key to avoiding recurrence of DTC P1109 and ensuring the longevity of vehicle components. Regular updates for the ECM/PCM software must be performed, as manufacturers continuously improve the functionality and resolve known issues. Inspections of wiring connections related to the BARO sensor should also be part of routine maintenance. Ensuring connectors are free of corrosion, clean, and secure can prevent signal degradation. Additionally, consistently monitoring vehicle diagnostics through the HDS can help catch potential issues before they escalate into more significant problems. Scheduling regular diagnostic checks and maintenance can save time and costs associated with unforeseen repairs, reinforcing the overall reliability of the vehicle. By incorporating these preventive measures, owners can enhance their vehicle's performance and avoid unexpected failures. In conclusion, DTC P1109 signals a significant issue with the barometric pressure sensor or its circuit, necessitating a systematic approach to troubleshooting. Understanding the components involved, their roles, and the potential causes is crucial to effectively diagnosing and rectifying the issue. Following the prescribed steps ensures that no further underlying problems are overlooked, allowing for a complete resolution. The importance of regular preventive maintenance cannot be overstated. Keeping software updated and electrical connections inspected can mitigate future risks. Therefore, by adhering to these guidelines and understanding the nature of DTC P1109, vehicle owners and technicians can work collaboratively toward maintaining vehicle reliability and optimal performance. Please like and subscribe to the channel. See you next time.